Hello, this is Mr. Wynn, and this video is the second part of the factoring polynomial expressions. So again, part 2. And this is very important. This is probably the most important video of all videos in Algebra 2. So the next method from before is the most important and most useful of all the methods. It only works for trinomials, which is 3 terms, and it comes from a pattern that we can discover while foiling. So notice I gave you this problem. 2x is 5 times x minus 3. You would, of course, foil. First, 2x times x, 2x squared. This is from the f. Outside 2x times negative 3, that's negative 6x, that's the O. Inside, there's I and L, it's last. Right? And when I combine terms, the F did not change. The L did not change either. Only the O and I combined into this middle term. Alright, so now we know that 2x squared minus x minus 15 actually was or came from 2x plus 5 times x minus 3. So that right side of the parentheses, that's factored form because it's one term. The left side is not factored form. So to figure out how to go from the left side, 2x squared minus x minus 15, into the right side factored form. And we use the fact that, hey, f did not change, L did not change. So what we do is we're going to guess and check. We have to figure out what multiplies to 2x squared. You have to have x in both. So we have basically 2 and 1. So 2x and 1x. You can also reverse that for 1x, 2x. But the good news is on the left side, the first term, you actually don't have to worry about the reverse. So I'm not even going to worry about that. The L, the last term, what multiplies to 15? Well, we have 1 and 15. We also have 15 and 1 with the reverse. We have 3 and 5. And we have 5 and 3. Right? We have to find the perfect pair. And we'll just put in parentheses and FOIL ourselves. So the first pair, I only have 2 and 1. So 2x and 1x. Right? So that goes there. Now the second pair goes on the right side. So the trick here is actually pick the smallest numbers first, the closest numbers I mean. So 1 and 15 is 14 apart, that's pretty far. 15 and 1 is pretty far. 3 and 5 is pretty close, so I'm going to put 3 here and 5 here. If I do the F, 2x times x is 2x squared. If I do the L, 3 times 5 is 15. So those are correct. I have to worry about the O and I. So when you guess and check, only try the O and I and FOIL. If I do the O, 2x times 5, well, that's 10x. If I do the I, 3 times x is 3x. And don't even worry about the signs yet. Now, can 10x and 3x ever make negative 1x? If you add or subtract them, no. If you do 10 plus 3, that's 13. If you do 10 minus 3, that's 7. It can only make 7 or 13, which is not 1, so that's out. We guessed the wrong number. So it was not 3 and 5. Now I'll try the reverse. Let me try 5 and 3. So those are still close. I do the FOIL again. I do the O and I. The O, 2x times 3, that's 6x. The I, 5x times 5 times x is 5x. Now can 6x and 5x ever make 1x? The answer is yes, because 6 minus 5 is 1. Now I care about the signs. I need a negative 1x. So to get negative 1x using those two numbers, I need the 6 to be negative and the 5 to be positive. So to get the 6, that was 2x times 3. I need to be negative. This has to be a negative 3. And for the 5x to be positive, this has to be a positive 3. And after you do the signs, you have to check one last thing. Check the sign of L. If I do positive 5 times negative 3, a positive times a negative is negative. It does match the sign of the last thing. We are good. So that is how you factor using guess and check. So I do a lot more problems, but this is very important. You can do this all the time in this class. This is the most important and useful skill. So we're going to do it again. Factor via guess and check. Again, only works if there's 3 terms. And the hint, like I said, always try the closest numbers together. And you still check for GCF first. So for this first term, there's 3 terms, there is no GCF. I'm going to do guess and check. Well, to make x squared, you only have 1x times 1x. So 1 and 1 is the only pair there. That's good. To make 6, you have 1 and 6, 6 and 1, 2 and 3, 3 and 2. The reverse matters. So I'm going to try to find the perfect pair for the first one. I'll try 1 and 1 first, so 1x and 1x. And then for the second one, I'm going to try the closest pair. Now actually, because the left side, x and x is exactly the same, they're identical, they're symmetric, you actually don't try the reverse. So if I do 1 and 6, that automatically takes care of 6 and 1. If I do 2 and 3, that automatically takes care of 3 and 2. So there's only 2 pairs here. Try the close one first. I'm going to try this 2 and 3. So I put 2 here and 3 here. I check the O and I. X times 3 is 3x. 2 times x is 2x. Can 3x and 2x make, they want 5x? The answer is yes, because 3 plus 2 is 5. Now I care about the sign. I need a positive 5x. So to get positive 5x, I need both of these to be positive. So the 3x has to be positive right there, and the 2x has to be positive. Then make sure you check the L for the sign. If I multiply that positive times a positive, it gives me a positive back. it matches this, we're good. So that is the answer. Alright, and you get a lot faster at doing this later on. This next one, 3 terms, x squared minus 13x minus 30. There is no GCF. I'm going to guess and check. Well, to make x squared, you just have 1 and 1. That's nice. It's symmetric. To make 30, you have 1 and 30, 2 and 15, 3 and 10, 5 and 6. And usually I write the reverse, but because 1 and 1 is symmetric, I don't have to write them backwards. Alright, I'll make the 2 parentheses. And I'll guess, well, for x, that's nice. The first one is x and x, because it's 1 and 1. And the second one, I'm going to pick the closest one. So I'm going to try 5 and 6. If I do O, x times 6 is 6x. I do I, 5 times x is 5x. Can 5x and 6x ever combine? We'll do the add or subtract into 13. Answer is no. So I picked the wrong pair. I'm going to guess another one. The next closest is 3 and 10. So let's try 3 and 10. If I do the O, that's 10x. I do the I, that's 3x. Can 10x and 3x ever make 13x? The answer is yes, because 10 plus 3 is 13. Now I need a negative 13, so I need to make this negative and this negative. Negative 10 minus 3 is negative 13. So this is the negative 10, this is negative 13, so that looks good. But remember, I have to check the sign of L. Negative 3 times negative 10, a negative negative is positive. This is a minus 30 though, so this is wrong. If it was a plus 30, I would have been right. So I guess the wrong pair again, even though it's really close. But you have to check the sign of L. So cross that out. I'll try the next one, 215. Alright, I do the O. X times 15 is 15x. I do the I. 2 times x is 2x. Can 15x and 2x ever make 13x? Answer is yes, because 15 minus 2 is 13. Now I need a negative 13, so the bigger number, 15, has to be negative, and then the 2 has to be positive. Alright, the negative 15x comes from this, the second term, and then the positive 2 comes from this. I check the sign of L. Positive times negative is negative. Oh, it's matching, so we're good. So that is the correct answer there. Alright, so we're just guessing and checking, but this is the fastest method. Alright, this next one looks very similar to the first one. Alright, so we know to get x squared, it's just 1x, 1x, 1 and 1. To get 6, you have 1, 6, you have 2, 3. And we don't have to write it backwards because it's 1 and 1, it's symmetric. So I make the 2 parentheses. First one has to be 1x, 1x. There's no other options. Now for the other one, I'm going to try the closer number, 2 and 3. So 2 there, 3 there. I do the O, that's 3x. I do the I, that's 2x. Can 2x and 3x make 5x? Yes. Now I need negative 5x, so I need both of these to be negative because negative 3 minus 2 is negative 5. So these are both negative. I check the L. Negative times negative is positive, but this is negative, so that means we got the wrong pair. Again, sometimes there's a pair that adds correctly to the middle number, but multiplies incorrectly to the last number. It's the sign that's off. So this did not work. I'll try the other one, 1 and 6. Alright, I do the O, that's 6x. I do the I, that's 1x. Can 6x and 1x make 5x? Yeah, 6x minus 1x is 5x. I need a negative 5x, so the 6 has to be negative and the 1 is positive. So the 6 is negative, this 1 is positive. I check the sign of L. Positive times negative is negative. It matches, we're good. That is the answer. Alright, so signs are very, very important. Alright, now a couple harder ones. Down here, it's still the same thing. Check 3 terms. Is there GCF? No. I figure out what multiplies to 2x squared. What's 2x times 1x? It's 2 and 1. Again, you don't have to flip it backwards. And for 5, well, this is 1 times 5 or 5 times 1. I do have to write it backwards because the left one, the first one, was not symmetric. Alright, I do the 2 parentheses. So 2x, 1x, and it doesn't matter, you just try one. I'll just go, you know what, I'll try this first one, 1, 5. If I do 1, 5, I do the O, 2x times 5 is 10x, I do the I, 1 times x is 1x. Can 10x and 1x make 7x? No, it can only add or subtract to 11 or 9. So that was the wrong pair. Alright, so that's out. I'm going to try the next one. I'll put 5 here and 1 there. Alright, so if I do the O and I now, 2x times 1x is 1 is 2x. Then 5 times x is 5x. Can 2x and 5x make 7x? Yes, you have to add them. 2 plus 5 is 7. I do the signs. I need a positive 7x, so both of these have to be positive. So the positive come from this being positive and this being positive. I check the L sign of L at least, so positive times positive is positive. It matches this last sign. We're good. So this is the answer. This next one, same idea. 1 multiplies to 3x squared. That's 3x times 1x, 3 and 1. Multiply 6, you have 1, 6, 6, 1, 2, 3, 3, 2. I had to write it backwards because the 3 and 1 is not symmetric, it's not the same number. Make the 2 parentheses. We have 3x and 1x. And then I just pick one. I pick the closest pair, so let's try 2, 3. 2, 3. I do O, that's 9x. I do I, that's 2x. Can 9x and 2x make 11x? Yes, I add them. I need positive 11, so this has to be positive 9. That makes positive 2. And a positive times a positive is a positive. It matches that sign, so we are good. All right, over here, last one, 3 times. There's a GCF, so you need to pull GCF. Otherwise, there'd be too many pairs. I could take out a 2. If I take out 2, what's left would be 2x squared minus 5x minus 3. Then the inside I care about. So what multiplies to 2x would be 2x times 1x. What was 3 is just 1, 3 or 3, 1 because I write it backwards. So I'm going to do the guess and check part. There's 2 weights out here, but I'll do 2 parentheses. This will be 2x and 1x. Let's just try the 1, 3 first. If I do 1, 3, I don't use blue. I do the O, that's 6x. I do the I, that's 1x. Can 6 and 1 make 6x and 1x make 5x? Yes, I subtract them. This has to be negative. This has to be positive. To get negative 6x, this 3 is a negative, and to get 1x, this 1 is a positive. I check the sign of L. Positive times negative is negative. It does match, so we are good. That is the answer. Alright, so that's how you do guess and check, but we'll practice a lot in school, in class. The last method is called grouping, and you only do it when there's 4 more terms. It's basically GCF twice. There are the steps. You divide the problem into 2 same-sized groups, take the GCF of each group separately. What's left in the parentheses has to match. If they do, that's our new GCF. Basically, every time you do GCF, half the terms go away. So we start at 4, it'll turn to 2. We do it again, it turns to 1, and we want 1 term because that's going to be factored form. Some hints are, if the parentheses are almost identical but have different signs, you need to take out GCF of -1 to make the signs match. And the parentheses have nothing in common, you got to rearrange the terms and make new groups. So here's the problem. With 4 terms, I'm going to make 2 groups. This will be one group right here, and this will be one group right here. For the first group, there's a GCF. They both have y in common. If I take out y, what's left would be x plus 2. And then for the second group, they both have a 3 in common. If I take it out, that would be x plus 2. Now notice, this is a positive 3. Now notice that they both have x plus 2 in common. But anyways, we have a new problem. Went from 4 terms to 2 terms. This y times x plus 2 thing plus the 3 times x plus 2 thing. These 2 terms have that same parenthesis in common, so I'll take that out. X plus 2. And what's left over would be the y and the plus 3. That is our final answer. Alright, this next one, I'm going to make 2 groups. So here's one group. I'll do it like this. I'll box it. This group and this group. This first one is a GCF of x squared. What's left would be 2x minus 3. For the GCF second group, there is no thing. But I can take out a 1. If I take out, I actually want to take out a -1 because I see it's negative 2x while I want a positive 2x. If I take out a -1, what's left over would be positive 2x minus 3. Now the parentheses are matching. So I can say, here's my new group together. This is 2 terms. They both have something in common, that 2x minus 3, so I'll take that out. And whatever's left in front goes in another parentheses, x squared minus 1. A lot of people stop here, but they mess up because x squared minus 1, this is a combination, is a difference of squares. I can square root this and square root that. To x and 1, so we know a is 1, b is, or x, a is x, b is 1. I would make 2 parentheses. Well, the first one stays the same. The second parentheses are 2 new ones, or difference of squares. So a goes first, x and x, b goes second, 1 and 1, plus minus. That is our answer there. Alright, this next one, I'm going to, if you notice the bottom left, these first 2 terms have nothing in common, no GCF. So what I'm going to do is I'm going to rearrange it. So I'm going to switch this and this. Actually, no. I'm going to move the x squareds next to each other. So I'll move these 2. So when you move things around, the sign follows it. So I'm going to pause it and do this. So let me just go to the very end. Once I switch that, the x squareds next together, I can finally make my 2 groups. Now I have one group that has x squared as a GCF, so I take that out. The other group, I have y as a GCF, so I take that out. And I actually take out a negative y to make the signs match. That final new group, the parentheses, 2 minus a is the same, so I put that as my final GCF. And whatever's in front, the x squared minus y, goes in the second parentheses. And that second one, I cannot do anything else because I cannot square root both x squared and y, so we're done there. That should be it. Thanks for watching. See you soon. Ask questions class. Bye.